It's the Applied Book, question 10F, question 4. And I'm going to assume that you've read the question. We're on page 176 to 177. And this is the setup that we've got. Oh dear, for some reason my string is floating off my pulley, never mind. So here is B, which has a mass of 3 kilograms, and the tension in the string is stopping it falling down. And here is A, which has a mass of 5 kilograms. So 5g newtons pulling down, 3g newtons pulling down. There is a tension in the string all the way along. Later on in the question we'll need the fact that those tensions are actually also pulling on that pulley. There's a normal reaction from the table, and in this question we don't have a smooth table, so we have a 24.5 Newton force which is pulling backwards. And we are asked to find the acceleration in the system and the tension in the string. So there are two things we can do. We can deal with particle A. We're going to have to think about the horizontal motion, and it's going to be F equals ma, because we know there is an acceleration. So the tension minus 24.5, that's the force, is the mass, which is 5, times the acceleration, which is a. And there's not much we can do to tidy that up, so we'll call it equation number 1. Then we'll consider B, its vertical motion, and its F equals ma, because there is an acceleration. So that is 3g minus t, that's the force, that's the net force on B, equals 3, which is the mass, times a, which is the acceleration. And that's equation number 2. Now if you look at this, we've got equation number 1, equation number 2, and there's a t and an a, and a t and an a. There is a g, but we know what the g is, so we can just deal with these as simultaneous equations. So I'm going to take equation number 1, I'm going to add it to equation number 2, and there's t and the minus t are going to cancel out, so I'm going to get 3g minus 24.5 on the left hand side. I'm going to get 8a on the right hand side. That's going to give me that 3g minus 24.5 divided by 8 equals a. So that means if we stick it on in the calculator, a equals 0.6125, and I think they give it a 613. I think they're following the convention of 3 decimal places in the back of the book. 0.613 meters per second. And that's actually part B, but once we've got to this stage here, it should be clear that you've got simultaneous equations to find t and a. It doesn't really matter which one you find first, it's just simultaneous equations techniques. In my head, it's easier to add these two equations together and get rid of the t. You might prefer to divide by 5 on this one and substitute the a into the second equation, or use a different method. Either way, it's all going to come out the same. Again, you should keep working down the page. I'm just going to squeeze it in here so I can try and get it on one screen a little bit more easily. I'm going to call this one line number 3, and I'm going to substitute line number 3 into, and it doesn't matter if it's equation 1 or 2, I've chosen equation number 1. So we get t minus 24 equals 5 times the acceleration, which is 0.613-ish. So t equals, rearrange this equation, and we plug all that through, and the answer in the back of the book to 3 significant figures, so I'll put an approximately equal because this is after the rounding, 27.6 newtons. Now that leaves us with part C, which is find the force on the pulley, and this is the situation. We know the tension is 27.6 newtons, so remember that number. We have this, here's our pulley, and we've got the string pulling that way with the tension on it, and the string pulling that way with the tension on it. So the tension, and that's the tension. So we want to know what's the overall force on the pulley. Well, we've got two forces, one pulling horizontally, one pulling vertically. So what we want to do there is really just add those two things together. So if you, there's a few different ways of thinking about it. One way of dealing with this is to think about it in this way. We've got t in the minus I direction, and we've got t in the minus j direction. So if you like, we've got the vector minus t, and that is the force that's pulling on this pulley. And if we want to find the magnitude of that force, we just need to find the magnitude of this vector. So 27.6, that's our force vector. So we're going to do the square root of 27.6 squared plus 27.6 squared. And when we do the squaring, these minus signs vanish. If you like, we can put them back in here. And then they will vanish. And if you work that out, you end up with 39-ish, 39 a little bit, which is the answer that we want.